All right, so get this. We're talking about the Andromeda Galaxy, right? And you know those ghostly streams of stars that swirl around it, like cosmic rivers,
Yeah.
Well, get ready to dive deep because what astronomers thought they knew about Andromeda's northwest stream, well, it just got turned on its head.
It's true. We're looking at this new research paper, and let me tell you, it throws a real curveball. You see, everyone thought this massive structure, this stream, was one single stream. Turns out it's more likely two distinct streams.
Two for the price of one, huh?
Exactly.
Okay. Now that's what I call a cosmic plot twist. And you know me, I love a good mystery. And this is sounding more and more like a case for, for those stellar sleuths out there.
Absolutely.
But before we get into the how, let's talk about the what. I mean, we're talking about structures so vast, they make a light year sound like a walk in the park. Just how big are we talking?
We're talking tens of thousands of light years across.
Wow.
That's wider than the distance between our sun
Right.
and the center of our own galaxy.
That's incredible.
Yeah, it's mind-boggling to even think about. And one of these streams, we think, might have its origin in a dwarf galaxy called Andromeda XD7.
Andromeda XD7, huh?
Yeah.
Sounds like a distant planet in Star Trek.
Right.
But hold on. How do astronomers even figure that out? Is it like looking for a needle in a cosmic haystack?
It does sound like science fiction, but it's really the work of astrophysics, right?
Yeah.
They're using these incredible telescopes and tracking the positions and speeds of stars within these streams. Then they run simulations, testing different scenarios to find, the best fit for the data. It's like putting together a giant cosmic jigsaw puzzle.
Wow. Okay, that's really impressive. But you mentioned cosmic breadcrumbs earlier. What were those exactly?
Ah, yes. The breadcrumbs. Those would be the globular clusters found scattered along the path of this second stream.
Globular clusters. Okay, for those of us who don't have a PhD in astrophysics, what are those again?
So imagine a giant swarm of ancient stars all huddled together in a ball, just held there by their own gravity.
Okay.
These clusters are like time capsules, you see, and they hold clues about the early universe. And finding them along this second stream really solidified the idea that, that we're looking at two distinct events in Andromeda's history rather than just one.
So it's like those clusters are whispering secrets about Andromeda's past.
Exactly.
That's incredible. But how did these streams even form in the first place? Was it a gentle process or more of a cosmic brawl?
Well, let's just say Andromeda wasn't afraid to, throw its weight around. These streams are basically the remnants of smaller galaxies that got a little too close. And, they were ripped apart by Andromeda's powerful gravity.
Whoa. Talk about a galactic turf war. We knew Andromeda was big, but I had no idea it had such a ravenous appetite.
Oh, it gets wilder. You see, this whole process of galactic cannibalism, it can tell us a lot about the invisible hand at play in all of this. We're talking about dark matter.
Dark matter. Okay, you knew we couldn't do a deep dive about galaxies without bumping into our old friend, right? The cosmic phantom,
right?
The stuff we can't see, but we know is out there, pulling the strings.
Yeah.
But what do these stellar streams tell us about dark matter that we didn't already know?
Well, that's a great question, and it's actually one of the reasons that this research is so exciting. These streams you see, they aren't just beautiful to look at. They're like cosmic beacons, right? They're illuminating the structure of dark matter around Andromeda.
Wait, I'm not sure I follow. How do we learn about something we can't even see by looking at something we can...
Okay, so imagine you can't see the wind, but you can see how it shapes a flag.
Okay, yeah.
Right. The flag's movement is going to reveal something about that unseen wind. These stellar streams, they're like flags.
Okay.
Their shapes are warped. They're stretched by this invisible hand of dark matter.
So by studying how these streams are distorted, astronomers can actually map out the dark matter surrounding Andromeda.
Right.
It's like they have X-ray vision, right?
Yeah.
For the universe's hidden side.
You got it. And the more we understand that distribution of dark matter, the closer we get to unlocking some of the universe's biggest mysteries, like how galaxies form and how they evolve over cosmic time.
Okay.
Yeah.
That's seriously cool. But you mentioned earlier that this research had some real curveballs, right?
It did.
We talked about the two streams, the dark matter connection. What else did the researchers uncover that made you go, whoa, hold on a second?
Well, one of the most fascinating aspects involves something called proper motion. Now, this isn't, the everyday motion we see when we look up at the night sky. We're talking about incredibly subtle movements of stars, across the sky over vast, vast stretches of time.
So not something you'd notice in a human lifetime.
Oh,
right?
no.
More like if you took a snapshot of the sky, say
No.
every few thousand years, and then compare them.
Exactly. It's like those time-lapse videos of glaciers moving. Right. Seems imperceptible at first, but over time, that change is dramatic. And what these researchers found is that the two streams in Andromeda, they are predicted to have opposite proper motions.
Wait, hold on. They're moving in opposite directions.
Yeah.
So it's not just a case of these streams, swirling around Andromeda together. They're engaged in their own, cosmic dance.
Precisely. And this discovery, it challenges some previous assumptions about how these streams behave. It's like watching this seemingly coordinated flock of birds suddenly break into two groups, each flying in a different direction. Makes you wonder what forces are at play, right? Pushing and pulling these streams across such vast distances.
And to think all of this is happening at a pace that makes even the slowest snail look like a speed demon.
I know.
It's mind-blowing how astronomers can even begin to measure these things.
Yeah, it takes incredible patience and cutting-edge technology and a whole lot of math, but the payoff is huge. Remember we talked earlier about how Andromeda has a bit of a habit of merging with smaller galaxies.
You mean its cosmic appetite for galactic snacks?
Mm-hmm.
Yeah, I don't think we'll be forgetting that anytime soon.
Well, by studying the aftermath of those mergers in Andromeda, we're essentially getting a sneak peek at our own galaxy's future.
Whoa, you mean?
You got it. The Milky Way is on a collision course with Andromeda.
Oh, wow.
Billions of years from now, these two galactic giants are going to engage in a cosmic dance of their own.
Okay, now my mind is officially blown. So by studying Andromeda's stellar streams, those cosmic breadcrumbs, we're not just learning about its past, but also getting a glimpse into the future of our own galaxy. That's intense.
It really puts things in perspective, doesn't it? But there's one more piece to this puzzle that we need to explore. You mentioned Andromeda's cosmic appetite earlier, and that's a perfect way to describe the process behind, how these streams are made in the first place. We're talking about tidal disruption.
Tidal disruption. Does that have something to do with black holes?
Not in this case, though. Those are fascinating, too. We're talking about the incredible gravitational forces at play when a massive galaxy like Andromeda, encounters a smaller one.
All right, tell me more. This is where things get really interesting. Okay, tidal disruption. You're about to explain how this is all about Andromeda's, shall we say, unique approach to interacting with its neighbors.
Right. Imagine a smaller galaxy, right? And it's just wandering a little too close to Andromeda.
Uh-huh.
And Andromeda, being the gravitational heavyweight that it is, starts to pull on that galaxy. But it's not an equal tug, you see.
Okay.
The side of that smaller galaxy facing Andromeda, it gets pulled much harder than the far side.
So basically like stretching out a cosmic pizza dough.
That's a great way to put it, except instead of dough, we're talking about stars and gas and dust, right?
Right.
And as Andromeda stretches that material out, that's how it forms those long, thin streams that we're calling stellar streams.
So every time we see one of these strings around Andromeda, we're essentially looking at the remnants of a galactic meal.
Precisely. They're like cosmic scars, and they tell this tale of Andromeda's rather dramatic past. But here's what I find truly fascinating. If Andromeda has all these streams from its past mergers, it makes you wonder about our own galaxy, doesn't it?
You mean, could the Milky Way have its own set of hidden streams?
Yeah.
Like a whole network of cosmic rivers that we haven't even discovered yet?
Exactly. It's highly likely that the Milky Way has a similarly messy past, filled with its own share of these galactic encounters. And we've already talked about the Sagittarius Dwarf Galaxy, right? How that's being torn apart by the Milky Way's gravity. Who's to say there aren't remnants of other ancient mergers out there just waiting to be found?
That's an incredible thought. But if these streams are so faint and so diffuse, how do we even begin to look for them?
Well, one of the most promising tools is data from the Gaia mission.
Ah, Gaia.
Exactly.
You might remember we've talked about Gaia before.
Yeah.
It's that incredible space telescope that's been, meticulously mapping over 1 billion stars in the Milky Way.
That's right, yeah.
Right? It's like creating this 3D map of our galaxy in unprecedented detail.
Exactly. And with all of that data, astronomers are starting to see things we've we've never seen before. Subtle patterns, faint structures, the whispers of the Milky Way's hidden history. And it's entirely possible that, well, that hidden within that data are the telltale signs of even more stellar streams just waiting to be discovered.
Okay, I have to admit I am hooked. I never thought I'd be this fascinated by something called a stellar stream, but, well, here we are. This deep dive has been full of surprises.
That's the beauty of astronomy, isn't it? It's a field full of surprises where every new discovery raises more questions than answers. And who knows, maybe one day you'll be the one to make the next big breakthrough, you know?
Yeah.
Uncovering a brand new stream in the Milky Way and, well, rewriting our understanding of the galaxy's history.
That would be incredible. But for now, I'll settle for the mind-blowing knowledge you've shared today. Thanks for taking this deep dive with us.
It was my pleasure.
And for all you listeners out there, keep looking up, keep asking those questions, and never stop exploring this vast, mysterious universe around us. Until next time, happy stargazing.